All right, plan for this recording is to talk through the review worksheet number 2. Hopefully this recording only takes one part, so this is part 1, but who knows, maybe it's going to be a long one, it's going to take 2 parts, but this is the review worksheet number 1. So the question number 1 through 4 is to answer all these questions: increasing, decreasing, concave up, concave down, etc. So in order to do those two things, we need the first derivative for increasing, decreasing, and we need second derivative for concave up, concave down. So let's just start by doing a couple derivatives. So y prime, basic power rule. Don't think there's any problem with that. 3x squared minus 12x. Y double prime is going to be 6x minus 12. Okay? All right, increasing, decreasing. We need to know where this thing is positive and negative. So we need to know where it's 0, because that's where it's going to switch from positive to negative. And then we're going to check each side of that. So I'm going to go 0 equals 3x squared plus or minus 12x. Factor out a 3x. And I get x minus 4. Okay, where's 3x equal to 0? And where's x minus 4 equal to 0? Okay, so once again, that is where my derivative is equal to 0, which is that means that's where my signs are going to change if they change. So I first find the zeros and then I check the left and the right to see where it's positive and negative. Okay, y double prime. Just a quick solve gives me x equals 2. I think we can all see that pretty quickly. A little algebra 1. All right, number line simply to help me organize. So put all my zeros. So my smallest 0 is 0. And then I got 2. And then we have 4. So my first derivative, I'm going to put up first. So f prime, I want to check to the left of 0. So plug a negative into this equation or this equation. They're the same equation. I'm going to plug it into here because it's easier to see. Putting in a negative here makes that negative. Putting in a negative here makes that negative. A negative times a negative is a positive. Something to the right of 0 but the left of 4. How about 2? Plugging in 2 makes that positive, makes that negative. A positive times a negative is negative. To the right of 4, this is positive. Something bigger than 4 minus 4 is positive. A positive times a positive is a positive. All right, so there's f prime, f double prime. I just have 1 0, so I'm checking to the left and to the right of 2. So plug in 0. 0 times 6 is 0, minus 12 is negative. And over here, plugging in something bigger than 2 gives me a positive. Okay? All right, so what does that tell me about f? Bummer, got that kind of close. Slide that down a little bit. So what does that tell me about f? So when it's f prime is positive, my f is increasing, and it is concave down because it's negative. In between here and here, it's f prime is negative, so my function is decreasing, and to the right it's increasing, and over here it is concave up. And when we do this kind of a representation of f, you can kind of see the increasing and decreasing does make a concave down. You can see the decreasing increase does make a concave up. So everything's kind of looking like it is supporting each other. So I think we're pretty good. All right. Next thing. Slide up here. Where is f increasing? So let's just answer the question. F is increasing, where first derivative is positive. So my f is increasing. Slide up here. F is increasing from negative infinity Again, that's always going to be a parentheses, but you can make this a bracket if you wanted to 0. And then we're going from 4 to infinity. Parentheses on the right. Okay, where's f decreasing? In between 0 and 4. Where's f concave up? Concave up to the right of 2. So we're going from 2 to infinity. And where it's concave down is to the left of 2. So from negative infinity to 2. Oops, wrong direction. 1 and 2 are done. Relative minima and maxima. Excuse me. Relative minimum would be over here at 4 because it's decreasing to increasing. So relative min at 4. And I want to plug that 4 back into my original function. And when I do that, where's my original function? Plug in 4 here, I get 64 minus 30. No, I get more than 64. No, I don't. 64 minus 96, negative 32. And relative max would be at this point right here at x equals 0. When I plug in 0, I get 0. So my relative max is at 0, comma 0. All right, coordinates of points of inflection. Points of inflection, where my second derivative is 0 or undefined. So critical values of my first derivative. So where my second derivative is 0 or undefined, and where it switches signs. So at 2 was my only 0, and did my f double prime switch signs? Yep. So 2 is also a point of inflection. When I plug 2 back in up here, I get 8 minus 24, which is negative 16. All right, and the final thing, sketch a graph. So let's just put all this key information on my graph. So I have a relative max at 0, 0. I have a relative min at 1, 2, 3, 4, and negative 32. We can kind of think about what my graph looks like. It's a cubic, so I kind of have an idea of what this thing should look like. So here's my relative min, here's my relative max. It switches concavity at 2, negative 16. That's my point of inflection. If we want to have some XY intercepts to get more precise, I set this thing equal to 0, and I get an x squared factors out of this, and I get x minus 6. So I know it has an x-intercept at 6. I wouldn't have required that, but we can do it, so we might as well. All right, so now my graph comes down. Whoops, I was going to miss that. Let's try that again. So it comes down, hits that point, and goes back down. It is just a sketch. Okay? Sorry, my pencil's not working well this morning. All right, there's question 1. Question 2. Same process. Y prime, 4x cubed, minus 24x squared. Y double prime equals 12x squared minus 48x. Set that equal to 0. And I get 0 equals, let's factor out a 4x out of the top. And I get x squared minus 6. Looks about right. No, I can factor out a 4x squared. I can take more out. Let's get rid of that. So we can take out a 4x squared and we get x minus 6. All right. Where is that 0? X equals 0. X equals 6. Y double prime. Set that thing equal to 0. I'm going to factor out a 12x. And I get x minus 4 left inside. And again, we have a 0 at 0 and at 4. All right. So we have something weird happening. We have a possible relative max min and a possible point of inflection at the same point. So something's going on there, and we'll discover that here in a second. So if I remember my questions right, we have first of all increasing, oh, this is my number line. That'll help us first. So where is f prime equal to 0? Whoops, I didn't want all that. So f prime is what I'm looking at, and that was 0 at 0, and out here at 6. F double prime is at 0 and at 4. And then we'll throw f in there here in a second. Okay. To the left of 0, this is always positive. This will be negative. To the right of 0, but less than 6, like 4, this is still positive. This is still negative. No sign change. To the right of 6, this is now positive. That's always positive. So there's positive. All right. At 0, to the left of 0 in f double prime, that's negative. That's negative, which gives me a positive to the right of 0. Between 0 and 4, like 2, that's positive. That's negative. It's negative. From 4 and up, greater than 4, that's positive. That's positive. This is positive. Okay, F. Decreasing to the left of 0. Decreasing still between 0 and 6. And increasing to the right of 6. F double prime is positive over here, so it's concave up. It's concave down. And over here, it's back to concave up. Kind of different. Okay, let's look at our functions. F is increasing from, looks like 6 and up. Look at my f prime, increasing where it's positive. So from 6, I'll be consistent. I used a bracket last time, so we'll stick with the bracket. So it's from 6 to infinity. Concave down. Or sorry, decreasing from negative infinity to 6. It never changed signs. Or yeah, never changed signs and never switched from increasing to decreasing at x equals 0. It just kept on decreasing. So that is a 6, and that is parentheses. So this whole entire time it's decreasing. You could argue that it's not decreasing at 0, it's flat, I agree, but you're going to see that included in most intervals. All right, concave up, where f double prime is positive. So looking at f double prime now, because it's concavity. So from a negative infinity up to concave up to 0, and between 4 and 6. Remember that U simply means we're putting these two sets together. We're unioning these two sets together. Concave down from 0 to 4, and that's it. Point of inflection where it switches concavity, and that happens at x equals 0. So my point would be 0, 0. And at x equals 4, it switches concavity. Plugging in 4 up there, I get negative 256. I cheated and used my answer key I'd already done earlier on that one. And another one at x equals 6. Nope, not at x equals 6. That's for my increasing, decreasing. All right, we're done. Let's sketch graph of this thing. All right, we have Oh, no, I didn't. I'm not done. Sorry. Relative max, min, etc. Okay, so relative min. Need to go from decreasing to increasing. Relative min goes from decreasing to increasing at 6. So my relative min will be 6, comma, negative 432. Relative max. I need to go from increasing to decreasing. Doesn't happen. There is no relative max. Did I get them all? Relative min, relative max, point of inflection, concave up, concave down. Let's sketch a graph. So we kind of, again, we know what this thing kind of looks like. It's a 4th degree polynomial. So it's going to have the same end behavior on the left and the right. So it's going to come from up here and it's going to end up there. We have a point of inflection at 0, 0. I mean, it's going to switch concavity. Relative min at 6. 1, 2, 3, 4, 5, 6. Negative 432. I'm just going to stick that down here a ways. Okay. And we have a no relative max. We have a point of inflection at 0, 0. So it switches concavity. All right. So I'm decreasing on this side, right? From 6 to infinity. Can't quite see that up there. Decreasing from, or sorry, increasing from 6 to infinity. So it's going to be going like this right here. Turns. And then what happens at 0, 0? So it didn't switch signs. So it's going to be a plateau point. So they're going to come up here. Wow, that was horrible. Try that again. I'm going to come from the other side. A little easier for me to drop left to right. Flatten. And then have her min. That wasn't the best at the bottom, but you got the idea. My point of inflection at 0, 0. It switches from concave up to concave down. Another point of inflection at 4, negative 256. It switches from concave down to concave up. And it stays concave up the rest of the way. Looks like we got it. Let me just double check our stuff. Decreasing. Yep, from negative infinity all the way to 6. Starts increasing from 6 to infinity. Okay? Concave down or concave up from negative infinity to 0. And then from 0 to 4, it's concave down. And from 4 to infinity, it's concave up again. Okay, looks pretty good. Question 3. So, y prime, same process. Y prime 2/3 times 3 is 2. Decrease by 1. Derivative of negative 3 is 0. Y double prime, negative 1/3 times 2. Decrease by 1. And we're done. Okay. Now, where is this equal to 0 or undefined? Okay, so this will never be 0, right? Remember, this is the same thing as 2 over the cube root of x. That'll never be 0. Why? Because the top will never be 0. So when is the bottom going to be 0? I do still have a critical value. So at x equals 0, it is still a critical value because it's undefined. It meaning my derivative is undefined. So x equals 0 is a critical value of the first derivative. This guy here, remember, we can rewrite this one as a negative 2/3. And this is going to be the cube root, the cube root of x. That's a 3 raised to the 4th power. Right, that's what that means. Top number is by power, bottom number is by root. All right, so that's what we have. So where is this 0? Never. It is undefined again at x equals 0. Let's go back to the original. Is this undefined at x equals 0? Because that's pretty important. And no, it's not. I can put in 0. 0 raised to the 2/3 power is still 0. Okay. So now jump down to my number line. What in the world's happening here? So f prime, put in something to the left of 0, like a -1. Can I put a -1 into a cube root? Absolutely. -1 cube root is a -1. 2 divided by that is negative. So we're looking at, well, there's only 1, so we'll just look at 0. To the left, this is negative. To the right, put in a positive number, we're going to get a positive number. Okay, f double prime. Put in a negative number. Negative number makes this positive. Cube root of a positive is a positive. Negative divided by a positive is a negative. Put in a positive. This is still positive. Negative divided by that is still negative. All right, so f is decreasing over here, and it is concave down over here. It's increasing over here, and it is concave, whoops. It is concave down still over here. Okay. All right. What's next? Min, max, etc. So we have relative min. Where is it switching from concave up? Sorry, where's it switching from decreasing to increasing? At 0. However, at x equals 0, oh, that's fine. At x equals 0, we got a -3. I thought it was undefined. It's not. All right, relative max. Switching from increasing to decreasing. Nope, doesn't happen. There is no relative max. Oh, I forgot all my other stuff. I'll just keep going on this route. Point of inflection. Where does it switch concavity? It doesn't. So there's no point of inflection, right? Concave down on this side, concave down on this side. There's no point of inflection. I just looked at my answer key. My answer key is wrong. Okay, it doesn't switch concavity. Is 0 a possible point of inflection? Absolutely. But it never switches concavity. So it's not a point of inflection. All right, I did not do all this stuff. So f is increasing where? Over the interval from 0 to infinity. Where is f decreasing? From negative infinity to 0. Where is f concave up? Never. Where's f concave down? Always. Except for, well, depends on how you read this. We're going to go our interval, negative infinity to 0 and 0 to infinity. Okay. Sketch a graph of this thing. So my only real critical value is 0, -3, right? 0, -3. 1, 2, 3. There is my relative min. It is concave down and increasing on this side. Concave down and increasing on this side. It is concave down and decreasing on this side. They should be symmetrical as best as we can. And there's my graph. Is this a critical value? Yes. Is it a differentiable point? No. It's a corner or a cusp. But it is a relative min. It is a critical value, making it a minimum. Okay. Number 4. Same process. Y prime. Derivative of 2 is 0. I'm going to treat this as x minus 1 to the -2nd power. So my derivative is going to be -2 x minus 1 to the -3. Using this same one right here, y double prime equals -3 times the -2 is a +6. x minus 1 to the negative 4. Now, I should point out, I am looking at the derivative of the inside function also. Okay, I am doing chain rule, but the derivative of x minus 1 is a times 1, which doesn't do anything. Same down here. We got a times 1. Okay? All right. Where is this thing equal to 0? I'm going to rewrite that. The negative 2 is going to go on top, and the x minus 1 to the third power is on the bottom. Here, a 6 is going to go on top, and an x minus 1 to the fourth power is on the bottom. Okay. Looking at my number line. Critical values. X equals 1 makes this undefined, and there's nothing that makes it 0. So x equals 1 is a critical value. X equals 1 makes this undefined, and there's nothing that makes it 0. So once again, 1 is my only critical value, and it's the same for the y prime and y double prime. So f prime, where is this? Or when I'm to the left of 1, this is like 0. This is negative. This is negative, makes this positive. To the right of 1, this is positive, like plug in 2. This is positive. This is negative, makes that negative. F double prime, to the left of 1, like 0. This is positive, because there's a fourth. This is positive. To the right of 1, this is positive. This is positive. So F is increasing on this side. It is decreasing on this side, and it is concave up on both sides. Okay? All right. Let's do our things. F is increasing on the interval from negative infinity to 1. F is decreasing from 1 to infinity. F is concave up always. Negative infinity to 1, 1 to infinity. F is decreasing, or sorry, concave down, never. Relative min. Relative min. Where does it go from decreasing to increasing? Relative min, never. Where does it go from increasing to decreasing? Relative max. Looks like it should be at 1. Here's a problem. Put 1 back in here. Y is not defined at 1. So there actually is not a relative max also, but it looks like there is on my number line, which is why we have to double check back in the original, and 1 is not defined in the original function. Y is not y is not defined in the original function at x equals 1. What does that mean? We have a vertical asymptote, right? This is an exponential, not an exponential, a rational function. So it's a rational function where my denominator is 0 at x equals 1, which makes a vertical asymptote there. That's important for the graph. All right, sketch a graph of that. All right, so at x equals 1, we just said that's our critical value, but it's not defined there. It is a vertical asymptote. It is concave up on this side. It is concave up on this side. It is increasing on this side. It is decreasing on this side. But what's happening as we get big or small? As x goes to infinity, this goes to 0, and 2 plus 0 is 2. I have a horizontal asymptote at 2. This question is bringing back all sorts of pre-calc stuff. So we have that. And we have that. Concave up on both sides. No relative max because this is not defined. There's no maximum. These go forever. There's no relative min because we never get to 2. It just keeps on getting closer. That all makes sense. My graph and my data match up. Okay, that page is super important. Make sure you can do that whole entire page. Increasing, decreasing, all that stuff. All right, a little more straightforward procedural type stuff. Give the coordinates of the relative min and max. Relative min and max, just got done doing. F prime. F prime of x equals 4x cubed minus 16x. Set that thing equal to 0, and I get, factoring out of 4x, I get an x squared minus 4. My zeros are at x equals 0, x equals 2, x equals negative 2. Okay, now we want to find the relative mins and maxes, and we want to justify our answer using one of the derivative tests. Nope, sorry, first derivative test. It tells me which one to use. So I'm just going to use a number line to help me identify my information. So we have negative 2, we have a 0, and we have a positive 2. Checking to the left of a negative 2, like a negative 3. Negative 3 makes this negative. Negative 3 makes this positive. Let me factor this one more time. It'll help when we plug in. So negative 3 makes that negative, makes that negative, makes that negative. We get a negative. Between negative 2 and negative 0, like, or sorry, negative 2 and 0, we get like negative 1. Negative, negative, positive. Negative times a negative times a positive is a positive. None of these factors are squared, so I'm pretty confident these just switch signs. So F goes from decreasing to increasing to decreasing to increasing. Okay, so are we okay with my statement before? I'm just going to cruise through it. Since these factors that give me the zeros are not squared, I shouldn't have a plateau point. It's going to switch signs. Okay. Relative min and max. Relative min goes from decreasing to increasing, like right there. So negative 2. Decreasing to increasing looks like also at a positive 2. Plug in those values to my original function. We get 2, 4, 8, 16 minus 32. I get negative 16. Same exact number here. So those are my two relative mins. Relative max goes from increasing to decreasing. Relative max is at 0. Plugging in 0, I get 0, and 0 is, which is 0. All right, I'm gonna let you read my answer key. By the first derivative test, here's what I wrote on my answer key. By the first derivative test, since f prime changes from decreasing to increasing, or from negative to positive, at both a negative 2 and at positive 2, these two values are relative mins. Also, since by first derivative test, since f prime goes from positive to negative at x equals 0, it is a relative max. Those words need to be written out. And again, if you look at the answer key, it is all written out. All right, question 6. Nope, question 5b. Same question. Give the coordinates for relative minimax, but this time we're using second derivative test. So I already know my critical values are at 0, negative 2, and positive 2. But now I need the second derivative. Second derivative, 12x squared minus 16. Second derivative, 12x squared minus 16. All right, second derivative test says we need to check concavity at those critical values. So f double prime of -2 is what I'm looking at. -2 squared is a positive 4 times 12 is 48 minus 16 is positive. F double prime of 0. 0 squared is 0 times 12 is 0 minus 16 is negative. F double prime of 2, exactly the same as -2 because that's squared and it's positive. Okay, so now I write in words, okay? By second derivative test, since f double prime at -2 is greater than 0 and f double prime of a positive 2 is greater than 0, this must be a relative maximum. Sorry, minimum, right? Concave up, this is a relative minimum. At 2, it's concave up, this is a relative minimum. One more time on the verbiage. By second derivative test, since f double prime of -2 and f double prime of positive 2 are both positive, they're both greater than 0, then -2, -16, and positive 2, -16 are both minimums. By second derivative test, since f double prime of 0 is less than 0, that means f of 0 or 0, 0 is a relative maximum, and those words need to be written. Key phrase, by the second derivative test. You have to say what it is you're using to tell you what you know. All right, points of inflection, where my second derivative is 0. So my possible points of inflection are at -2, sorry, still coughing this morning, -2, 0, and 2. Those are my possible points of inflection. So now I look back at my second derivative. At -2, it's positive. So, but now I got to check on the left-hand side and the right-hand side of it. So at -2, so like left of -2, I should do my number line to show you what I'm doing. Same as I did before, but now we're using second derivative, not first. I know here, here, and here it's 0. So what about to the left of it, like -3? I put a -3 into this, I get a big number, like what, 108? Minus 16 is positive. Put in something between here and here, like a -1. That becomes 12, minus 16 is negative. Between and here, like a +1. Same, right? Oh, sorry, what am I doing? I am doing critical values of the first derivative. Hopefully you guys were yelling at me at that point in time. It's about 5 o'clock in the morning on Saturday, so I have an excuse. All right, let's try this again. Where's my second derivative equal to 0? 12x squared minus 16. Add 16 to both sides. Divide by 12. Take the square root, and I get 4 plus or minus over root 12 equals x. We could reduce that some. I do on my answer key. I get plus or minus. 12 can be broken down into, I'll just show you what I did. 4 and 3. Square root of 4 is 2. So the bottom becomes 2 root 3, which can be broken down into 2 over root 3, which can be broken down into 2 root 3 over 3. So there's where that whole mess came from. Now that you've seen it, I'm going to erase it. Just jump to the chase to save room. So this becomes plus or minus 2 root 3 over 3. Those are my two possible points of inflection. So I have the -1 over here, and I have the +1 over here. plug in something less than this value here. What's less than that? Something like -2. Okay, -2 squared is +4 times 12 is 48 minus 32 is positive, or minus 16 is +32. Plug in something like 0, makes that a -16. Plug in something like 4, makes that a positive. Are these points of inflection? Yep. Why? This is where your second derivative is 0, and it switches signs at each of them. So my points of inflection, -2 √3 over 3. Take that value, plug it back into my original function way up here. Not that far up. Plug it into here, and you should get -80 over 9. Okay, and I could show all that, but I think you can do that. Now, if I plug in both of these, that is also the same value. So I'm just going to cheat and go when x is plus or minus that value. Because notice, because of the even power, because of the even exponent, you're going to get the same value, whether you put in a positive or negative 2 √3 over 3. Okay, now this is just summarizing your information that we already have. Okay, there's no more work to be done here. Over what intervals is my graph increasing? Go back up here to the original. Increasing from a -2 to 0, increasing from 2 to infinity. Where is it decreasing? From -infinity to -2, and from 0 to 2. And that's on the answer key. I don't need to rewrite that. Okay. Super important you can do all that. That's another big question. Same as basically the front page, just written out a little different. Okay, we haven't done any of these before. This is kind of just interesting. Whoops. I'm going to cheat. So let's just draw a little XY axis here. And let's sketch a graph. All right, so here's all the information we're going to use to graph. So first thing, f of 2 is equal to 1. So they're giving me some values for my graph. F of 0 is a -2. So I have those two values. I know that f prime is greater than 0 when x is between 0 and 2. So my original function is going to be increasing from these 2 points. Hey, 1 second. I'm making a recording. All right, sorry about that. I had a phone call right in the middle. My ringer was on, and I have no idea where I was at. So I think what I was saying is talking through this part right here. Since my f prime is positive, my function is increasing between these 2 points. Okay. F of -2, f of 0, f prime of -2. Wow. F prime of 2 and f prime of 0 are both 0. So these are possible mins and maxes at 0, and at 2. Okay. When f prime is, or when x is greater than 2, f prime is negative, making it decreasing on this side. And when it's less than 0, it is also negative, making it decreasing on this side. All right, so decreasing, let's just work our way across. From less than 0, it's decreasing over here. When I get to 0, it's increasing from 0 to 2, looking at this information here. And when I get to the other side of 2, it's back to decreasing. And it is a 0 at these 2. So I know my graph looks something like decreasing, 0, increasing, 0, decreasing. So upside down cubic. So that's good practice to go through. Normally we go from a graph to that information. Now we're just going from that information to a graph. All right, let's do it again. All right, again, we have one piece of information. F of 1 is 3. Next thing we know, f of 1 is also a min or a max, or a plateau point. Okay, because it's f prime of 1 is equal to 0. So this is the critical value, is about all we know. Okay, f double prime of 1 is 0. It's a critical value for f prime, and it's a critical value for f double prime. So it's possible min max, possible point of inflection. All right, f prime of x is less than or equal to, that key phrase there, or equal to 0. This fancy symbol means for all x's. F prime is less than 0. F prime is negative. My function is decreasing or 0 for all x's. Do you see how I translated that? My original function is decreasing for all x's. So what does that mean? So it's going to come like this. It flattens here. How do I flatten there? Oh, because of this guy right here. My graph is going to decrease, flatten for a second, and then keep on going. Does that make sense with this information? F double prime is concave up, or sorry, my function is concave up when it's less than 1. Yep, that makes sense. And my function is concave down when it's greater than 1. Yep, so I have a upside down cubic again with no relative min maxes. And there we go. All right, number 8. Try it again. So I have no points this time. All right, let's just start working our way through all the information. My original function is increasing when it's less than 0 and decreasing when it's greater than 0. My function is increasing on this side, decreasing on this side. I guess I didn't know that. I kind of drew the shape of it. It's increasing on this side. It is decreasing on this side. This could be a point or a max or min, possibly. All right, let's look at this. As x goes to 0 from the right, my function goes to infinity. As x goes to 0 from the left, my function goes to infinity. So yep, now what I drew is right. So I know it goes to infinity here, and it goes to infinity here. When x goes to infinity now, or negative infinity, it goes to 0. So that's on the other axis. So we're cruising down here, goes to that one, and we're cruising down here to that one. Can't get my board in the right spot to draw it. There we go. All right, last one. My graph is concave up when x is not 0. Are both of these concave up? Yep. My graph is increasing. My graph is decreasing. Concave up everywhere. Looks good. All right, so there's that. Question 9. That was on that other screen, was it? Oh, question 9 is on that screen. All right. Question 9. Find absolute extrema. So I'm thinking critical values and endpoints. Absolute extrema, critical values and endpoints. Critical values, f prime of x equals 4 times a fourth, which is just x, raised to the third power, minus 4x. Set it equals 0, factor out an x. We've done one like this before. We get x minus 2, x plus 2. That's an x and not a v. All right, there is my factored form. What makes that 0? X equals 0, x equals 2, x equals negative 2. Those are my critical values. Now, do I need to make a number line and do the whole first derivative test, increasing, decreasing stuff? Nope. Absolute extrema. All I care about are those critical values and the endpoints. That's it. So I'm just going to start working through. Start at f of -3, do f of -2, and again, I kind of like to do them in numerical order. Does not matter one bit. Put them in whatever order you want. Just get them all on the paper. And yes, you have to show all of them. If you don't, you're not proving that you found the maximum because you're leaving something out. You have to show all of them. Okay, f of -3. What I would do is I would type this function into my calculator, hit store as f of x, and then do f of -3, etc. That's what I did. You can do it by hand. You're not going to be required to do this many by hand. Would I have a problem like this where you have a fraction with something with like 2 numbers? Sure. But I assume you can number crunch those. So I'm not going to do all that. And you can see on my paper, on my answer key, the values you get when you plug all those in. And just circle the min and the max. So in this case, I happen to have 2 values that are the same, that are the smallest. So there is my absolute min, and there's my absolute max. And these are just critical values. Okay, last one. Almost an hour recording. It will be an hour by the time we're done. All right, oil wells offshore, 2 kilometers off the coast. And we have a refinery that is 4 kilometers down the coast. Oh, it's not the last one. There's 2 more. So here's my scenario. Here's my oil well. I guess it doesn't say oil, but I assumed it was oil. We have 2 kilometers off the coast. And the question is, laying pipe in the ocean is twice as expensive as on land. What path should the pipe follow in order to minimize the cost? So do we want to go straight to shore and then run down the shore? What are we gonna do here? So here's my refinery, and we have some distance we're gonna aim for. So I'm just gonna pick this guy right here and call that X. If I were to just come straight to the coast and then down the coast, X would just come out to be 0. So X is just some number. It could be, I'm gonna go straight for the refinery and keep it all in the water because that's the shortest distance. It's not gonna come out that way, but it could be. All right, so this distance over here is 4 minus whatever X comes out to be. Okay, distance of the pipe is from here to here and from here to here. A squared plus B squared equals C squared makes this X squared plus 4. And this distance here is just 4 minus X squared. So cost, trying to minimize cost. Remember optimization problems. Write the equation of what you're trying to minimize or maximize. So cost, whatever cost is going to be, it's 2 times, and you could put some letter here like 2 times K for cost. It turns out it doesn't matter. I'm just, because when we take the derivative, it's going to go away. So I'm just going to leave it out. So it's twice that distance plus that distance. There's my definition of cost. And again, I could have a K right here, and I could have a K onto here, but it turns out it doesn't matter. And again, K just meaning, or A or B or whatever you want, representing the cost per foot, cost per kilometer. Okay. Minimize the cost. How do you find minimums? We find the derivative. We set it equal to 0 or where it's undefined, and we do our whole relative minimum maximum thing. So derivative of this. Remember, this is X squared plus 4 to the 1/2 power. If this were a calculator question, you would just type it into the calculator. But we can do this without a calculator, so let's just do it. 1/2 times 2 is 1. Decrease the exponent by 1. Leave the inside function alone, and this becomes a negative 1/2 times the derivative of the inside function, which is 2x. Derivative of 4 is 0. Derivative of x is a negative 1. Okay, do a little rewriting. I get 0 equals, that 2x is going to slide on top. The x squared plus 4 is going to go to the bottom, and we could do the square root. I'm gonna leave it as a 1/2 just because I already wrote it. And then I have this -1 out here. Set it equals 0. I'm going to add 1. And I get this. I'll go ahead and rewrite it now. Cross multiply. Square both sides. Subtract x squared. Divide by 3. Take the square root. And there's my x. Okay, what does that mean? So I want to shoot for a point that is 2 divided by square root of 3 units or kilometers down the beach. And then this is going to be whatever's left. Okay, what path should they follow? That right there. Shoot for a point that is 2 square roots of 3 down the beach from straight offshore. Okay. All right. We need an XY axis. I'm going to draw one again. And we know that the first quadrant has coordinate axis as sides of this triangle, and it passes to the point 1, 8. So that point right there is on the hypotenuse. The hypotenuse passes through the point 1, 8. So my hypotenuse or my graph looks something like that. Okay? I don't know where these points hit. Okay? It's just my graph looks something like that. Okay. There's a couple ways of thinking about it. I'm going to try it this way, see if this one makes sense. I need an equation for this line, or I need a length of the hypotenuse, right? So I need an equation for this line. Let's just set this slope and this slope equal to each other to find our equation. So this is 0 some value for y. This is x comma 0. So I'm going to split this up. This slope and this slope has to be the same. So this point right here is 1, 8. So it's y2 minus y1 over x2 minus x1 equals, go over to here, y2 minus y1 over x2 minus x1. Do a little simplifying. I get y minus 8 over a -1. I don't need that parentheses. Equals a -8 over x minus 1. Do a little cross multiplying. So I multiply this by -1. I get y minus 8 equals a positive 8 over x minus 1. Add 8, and there's my equation for that hypotenuse line. Okay, now my distance formula, distance from here to here, is the square root of x squared plus y squared. The distance from here to here is x squared plus y squared square rooted. Substitute in the value of y we just found. I would grab a calculator at this point. Take the derivative. Set that derivative equals 0 and solve. And when I did that, I got x equals 5. So this value is 5. What was the question? Find the length of the the vertices. So this is 5 comma 0. Plug in 5 here, and I get y equals 8 over 5 minus 1, which is 4, plus 1. So 8 minus divided by 4 is 2, plus 1 is, that can't be. X equals 5. Oh, that's not plus 1. That's plus 8. And hopefully you caught that. I typed it into the calculator right. I promise. The numbers are right. This is plus 8 though. All right, 8 divided by 4 is 2, plus 8 is not 3. Hopefully we see why I was stumped, because 3 can't work. That's 10. So this is 5, that's 10, and that are 2 coordinates. And the review worksheet is done. Am I right? No, one more. Man, I want this to be done. Keep trying to, wow, I can't talk even. Keep trying to get it to be done, and we have one more. This is the last one. All right, sketch graph of f prime. Here's my graph. Sketch the graph of f prime given the graph of f. Yep, here's your f. I want f prime. First thing I would do, my derivatives are 0 at mins and maxes. So my derivative will pass through the x-axis at mins and maxes. My function is decreasing, so my derivatives will be negative. They're negative until I get to here. My function is increasing, so my derivatives will be positive. So why does it curve like that? Because my slopes are really steep over here, or more steep, so they're bigger negative numbers. As I get to here, my slope is flatter, so my negative numbers are smaller. They're closer to 0, so it's going to come up and get to 0 right here. Same thing. They're kind of flat, so they're small, and then as I go, they're getting steeper and steeper. Right here, it's the steepest, so I have a highest derivative, and then it goes to 0 here. And so I have a parabola looking shape, which should make sense. This is cubic, and when I take the derivative, I decrease the x-norm by 1, making this a quadratic. All right, this one over here is a little different. How in the world do we do this one? Same idea. I have a 0 here. I have a 0 here. Well, what about this guy right here? We'll get to that here in a second. So over here, my graph is increasing, so my derivatives are positive, so it'll come down from here. My graph is decreasing, so my derivatives are negative until I get to here. It's not a quadratic looking shape here. My graph is increasing, so my derivatives are positive. And when I get to this value right here, that is not differentiable. So I have an open circle over here. This is a straight line. What is the rate of change of that straight line? Constant. So this is a negative slope. So my derivative is some negative value. I don't know what it is. Open circle, because I can't take the derivative there. And it is a flat line. Is there a derivative of all these? Yes. It's not 0. It is some constant slope, like a -2 slope or -4 or something like that. And I'm done. Okay, now we're done. Hope that helped. I'll get it posted.